Hello, everyone, and welcome to another Exploring Forest Resilience webinar organized by Resonate and ONEforest projects, both funded by the Horizon 2020 program of the European Commission. This webinar aims to share studies on forest resilience from our researchers and PhDs. So today we have from ONEforest side, Javier de Dios, researcher at CC4 in Spain, and he is going to talk about enhancing forest production through water stress amelioration in European black pine forests. The floor is yours.
Okay, so thank you for inviting me. My name is Javier de Dios. I work for CC4 in Spain, and I'm going to present one of the studies from ONEforest in the Mediterranean area. In the last years, we have seen in many countries in Europe heat waves. We've had summer droughts and water shortages. I think we're all aware that water is becoming scarcer. And these changes in the climate affect water balance, but also tree growth and the wood we obtain from trees. So to address this topic in European forests, we came up with two questions. Can forest management alleviate drought stress in European black pine forests? Can different management alternatives alter the effect of drought stress on wood production compared to a no management baseline, a control baseline? So ONEforest aims to ensure the protection of multifunctional Mediterranean forests to provide multiple ecosystem services. It also aims to evaluate different management alternatives that reduce forest vulnerability to climate change and enhance forest resistance and resilience to fires. It also aims to assess the potential of different management alternatives to provide wood of the required quality and quantity as demanded by the market. So why black pine? Why do we study black pine? European black pine is a fast-growing conifer. It's one of the most economically important native conifers in the south of Europe. It has a durable wood, which is used for indoor flooring, furniture, fuel wood, and poles. And it's been widely used to control soil erosion in reforestation projects. So where have we done this? We have established a set of 22 plots in 3 countries. We have 2 sites in Spain, another one in Italy, and another one in Slovenia. These 22 plots are located on pure stands where 80% of the total basal area is from Pinus nigra, and they are established under different management alternatives from even age to uneven age to plantations. And we have covered all age ranges from young to mature stands. In this table, you can see the distribution of plots by countries. We have some plots that were managed, that were thin, and other ones that were used as control. Okay. So we have sampled trees from these plots under different management alternatives. So for the trees, we have measured the diameters, we have measured the heights. We have also sampled shrubs and seedlings because they are all important for the water balance of the forest. And we have also sampled soils, and we have extracted cores from these trees. So we have processed this data and harmonized them between countries, and we're carrying out the modeling process with an R package that's called MedFate. This package was developed by Miquel de Cáceres. He works in the CREAF in Spain, and we're working together with him for this study. So what we're doing with this data is studying the water balance in black pine forests under different management schedules. We're looking to have a daily picture of this kind for each of the 22 plots we have in Europe. So we would like to know the daily temperature in each of these plots for a period of time. Also the rainfall that's intercepted by trees growing in each of these stands. And we want to know the transpiration under different management schedules. And we also want to know the water that's infiltrated by the soil that then percolates and drains, because all this is important for the hydraulic redistribution, for the forest water balance. So what do we expect from this? We know that management defines the forest structure. It modifies the interception and also the transpiration and the water balance. So an enhanced water balance will result in water stress alleviation for trees. And improved management schedules may result in an increased forest production or a lower risk of fires. For example, um, here are some pictures from the collaborators in the study. We are four institutions working on this study, CESE4, where I work with my boss, Roberto Rubio, also CTFC, who is leading this study, where Edu and Miriam Piquet work. And we also have Tuscany region with Andrea and Tony, and Dusan from the University of Ljubljana. And this is it. Thank you. And I'm happy to answer to any questions you may have.